This week we're going beyond matplotlib. And we're going beyond because while matplotlib is a great and very versatile library, there are some situations where it is lacking. So for example, even for simple plots, matplotlib often requires a lot of code. And to make matplotlib plots look pretty, we often need even more code. And sometimes we also want our plots to be interactive. And that's something that matplotlib cannot provide. And so this week we'll look at pandas plotting, which is a great way of visualizing our data, sometimes even with just a single function call. Then we will also have a look at Seaborn, which is a very powerful plotting tool that also looks really nice. And then finally we'll look at Plotly and Jupyter widgets, which allow us to add interactivity to our plots. And to make all these packages work, we provide you with a requirements file that you can simply install with pip install -r and then the file name. The data that we're working with is from the Vega dataset. And it's about cars, so we have, for example, name, cylinders, displacement, horsepower, year or origin. The second dataset that we will work with is the Titanic dataset. Here we have IDs for different passengers, whether they survived or not, their class, name, and so on. And to give you a small teaser of what these new plotting libraries can do, let's first have a look at Seaborn. So here we import Seaborn as SNS and then call the sns.pairplot and pass to that the cars data. And this gives us this overview plot here, where all the columns of the data frame are plotted against each other. And this allows us to check how variables correlate. So for example, we see here there's a correlation, and that happens between the displacement and the horsepower. Here we can see a plot generated with Plotly, a library that allows for interactive plots. And we can see that while hovering over this plot, some different things pop up, and we can even zoom into our plot. And of course, there's a lot more that we can do. Finally, a teaser for the widgets. Here we see the Titanic data plotted, and what is being plotted is the sex distribution for different ages. And the Jupyter widgets allow us to change this age range. So you can set the lower bound to almost 0, and the upper bound first to the highest value maybe, and then we can see there are more males than females. And as we now decrease this upper bound, we see that this is slightly changing, and in this age range, so from 0 for 2 years to almost 15, the sex distribution is equal. So this can be really useful for exploring our data. And exploring our data is very important for data analysis. And this exploration we can do with statistical visualization. So we want to represent our data as plots, because humans are very good at processing visual information, but not that good at processing raw numbers. And so to help us explore, we visualize our data. So let's start with pandas plotting. The plotting functions provided by pandas are probably the quickest way of how we can visualize our data frames. And the cool thing is that we can even customize these plots using matplotlib. The downside is that these plotting functions are somewhat limited. And even though they do their job of visualizing our data, the visualizations themselves don't always look that great. So let's look at some examples. We have again our cars dataset. And the dataset contains some NA values, which we can see here, and we'll fill them up using the median. And here's the Titanic dataset, which doesn't contain any missing values. So let's look at the pandas plotting. For that, we first create a figure and axis object using the pyplot submodule from matplotlib. So we call plt.subplots. And then instead of calling a plot function on our axis object, we call a plotting function on our data frame column. So on the Titanic H column, we call .hist, which stands for histogram. And with that, we can very easily create a histogram plot of our column. If we're not satisfied with the look of that, we can also change up the style. So we call plt.style.use and pass, for example, the classic style. And then we run the same code, and that gives us then this classic look here. And we already talked a lot about Seaborn looking very nice, and so we can also use Seaborn as a style. So we call sns.set and then run our code, and that will create a plot in the Seaborn style, but using all the syntax from matplotlib and the pandas plotting functions. Okay, next up is Seaborn. And Seaborn is built on top of matplotlib, and it's a very powerful plotting library that makes it very easy to create nice looking plots with just a few simple lines of code. The downside is that it's not easily composable, so adding multiple plots together can be challenging. And even though there are a lot of default plots that Seaborn provides which do work very well for most purposes, if we have to go outside of these default use cases, things can get messy. So if you don't see the plot that you want in the Seaborn gallery, maybe it's best to go back to matplotlib. So let's have a look at some of Seaborn's plots. We again load our dataset and then again run this overview plot. Seaborn also has aesthetic mappings. So we can change the hue depending on some column. And so here we pass to the hue the name of the origin column. And so now the data points in our plot are differentiated by origin, which can be very helpful for exploring our data. We can also explore a single variable, for example by calling SNS this plot on some column, so here on the acceleration column, and that will then tell us how the acceleration values are distributed. The same also works as a box plot. We can also explore the relation of one continuous and one categorical variable. So here origin is our categorical variable, and then we're interested in how acceleration changes depending on origin. So on Y we have acceleration, and it's again plotted as a box plot, and then on the x-axis we have the origin. Alternatively, we can also do that with a jitter plot, or here called swarm plot. If we want to combine multiple plots, we can just call the functions after each other. So here we first call the box plot, and then we call the swarm plot. And that will then combine both plots. We can also do violin plots, and we can make our plot a little bit more interesting by creating a binary variable that tells us if a car is old or new. And we create this variable by using pd.cut, and so we cut the year column into either old or young using 2 bins. So the cut will happen in the middle such that we have equally many old cars as new cars. And then we can again change the hue of our plot using this binary variable. So now in our violin plot, we're also differentiating between age. And now we could say, for example, that younger cars in the USA tend to have a slightly higher acceleration than older cars. We can also explore the relation of 2 continuous variables, and we can do it with a giant plot. So we see here in the main plot how the 2 values correlate. So here in this case horsepower and weight, and as we can see they correlate positively, which makes sense since usually higher horsepower also requires a bigger engine, so more weight. And then on these sides here we can see how the individual variables are distributed. So that's for horsepower, that's for weight. There are also different kind of giant plots. So for example there's the hex option, which creates this plot here, or we can pass the reg, which stands for regression, and that adds a regression line here. We can also do kernel density estimation, which gives us this plot here. If we want just a simple plot with this regression line, we can use the LM plot. And now to get multiple plots, we can use the column and row arguments. So here we pass to the column argument the name origin, and this will create then column-wise plots for each of the origins, so USA, Europe or Japan. We can also create more complex facet plots by first creating a facet grid. So for that we also define row and column of this facet grid. So in rows we want cylinders and columns should be years, and then we want to, for example, map a histogram plot on that for the horsepower. So we can then see we have all these horsepower histogram plots. So for all of these we have horsepower here and frequency of the values here on Y. And then the top or title of our plot describes the position in the facet grid. So the grid was built from cylinders and years, and so the cylinders change in the downwards direction. So here it's cylinders is 3, then 4, and 5, and years change in that direction. So 70s, 71, 72. And so doing that we're covering all the different combinations. Finally, we can have a look at the Seaborn gallery, which is the best place to start when you're looking for a specific way of plotting your data. So you can scroll through here until you find something that suits your needs, and then simply click on that, and then you get the code.